Welcome to Model-Based Development with eFMI. In the next 7 minutes, you'll learn about the new eFMI standard, its motivation, application and benefits. eFMI is one of the key achievements of the publicly funded European ITER project emphasis over the past 3.5 years. The eFMI specification has been handed over to the Modelica Association recently for further development and preparation of the first official release expected within 2021. The emphasis project with 25 partners from 5 countries was led by Professor Martin Otter from DLR and Oliver Leonard from Bosch Corporate Research. The partners of the consortium and the members of the associated OEM advisory board cover the entire value chain from physical modeling to ECU software, including tool vendors as well as automotive suppliers and OEMs. Leading companies ensured a good market access. The OEM advisory board provided the market pull and direction. All partners, even competing companies, joined forces to work out a conceptually compelling and technically outstanding open standard to enable new ways of model-based development of ECU software. The motivation for Bosch Corporate Research to initiate this project back in 2015 was driven by the business needs expressed by our industrial partners in the Bosch business units. A growing software stack whose complexity has become a threat in terms of maintenance costs and the limiting factor for new innovative functions for systems of an increasing complexity. New ways of developing embedded software in a faster and more sustainable way was the ambitious project goal. Starting point of the eFMI approach is the observation that understanding how things work is fundamental for developing successful products. Modeling and simulation has been used over decades to build up and utilize this knowledge. Thousands of engineers at Bosch leverage simulation techniques to build the high-quality products we are selling worldwide. With code being the fuel of the 21st century, software has become a driver for new innovations for smarter products. Finding ways to dissolve simulation models into software to inject them directly into the products is the key to derive advanced functions faster. Bridging the gap between the modeling and simulation domain and the embedded software world is the core idea behind the emphasis project, leading to eFMI as new exchange format between these domains. The idea has not only been specified on paper in form of the eFMI specification, but also realized by a large number of tools, from modeling tools over ECU code generating tools to validation and verification tools. With 13 tool prototypes at a high level of maturity, one could say that eFMI is already established before it's even officially released. The developed toolchain has been thoroughly tested and cross-checked. An eFMU compliance checker is available open source for everybody to verify their own implementations against the standard. Key for Bosch was to assess the quality of the generated code. It was obvious to us that compromising on runtime performance and resource demand would undermine the user acceptance. A better productivity through an automated process was considered acceptable at the cost of plus 25%. 6 test cases have been defined by our expert embedded software developers and manually implemented to be the baseline for the benchmark of the eFMU code, evaluated on a real Bosch MDG1 control unit. As a result of this assessment, did the auto-generated code in all cases reach the KPI of less than 25%? And to our surprise, even outperformed the hand-coded solution in 5 out of 6 examples. This is a technically outstanding result. Furthermore, the working hours have been counted for both the eFMI workflow and the state-of-the-art manual implementation. As a result, it could be shown that especially for the examples taking advantage of a high level of reuse based on Modelica libraries, a tremendous gain in productivity can be achieved. Bottom line, eFMI enables better code with less effort. Over the course of the project, 9 demonstrators have been developed to showcase and evaluate the industrial-grade readiness of the eFMI toolchain. The impressive results include a wide variety of physics-based state estimators that convinced not only our industrial partners, but also the ITEA review board to consider the emphasis project with excellent ratings. Finally, we are looking forward to the ITEA award ceremony in September 2021, when the emphasis project will be honored with a Vice Chairman Award of Excellence for outstanding results in all 3 categories: innovation, business impact, and standardization. This brings us back to our initial goals. As briefly outlined in this talk, by tearing down the walls between physical modeling and embedded software, the overall productivity can be largely improved. The eFMI workflow helps to manage complexity better by separation of concerns and allowing to manage complex systems on a higher level of abstraction. Finally, all this is an enabler of new software innovations for suppliers and OEMs to sell more and more advanced functions, and to vendors to be among the first to provide tool support for this breaking technology. As a closing note, I want to refer to what the members of our OEM advisory board said. These positive statements encourage us to expect a strong market pull for eFMI, so that in a couple of years from now we can truly say, yes, eFMI has revolutionized the model-based development of embedded software. Does all this sound interesting to you? Don't hesitate to contact us. We're looking forward to welcome you in the eFMI community. You want to get involved? Then become member of the new Modelica Association project MAP eFMI. Thanks for watching.